Hey everyone, welcome back. Finally, it's the moment we all have been waiting for. In this demo, we will be generating embeddings and storing those embeddings in Chroma DB. And then we will perform some semantic search queries using Chroma DB. So without wasting any time, let's dive in. Okay, so it's time for a live demo. In this demo, we will be storing and querying vector embeddings using Chroma DB. So the first step here is to import the required packages. We need the GenAI package from Google for creating the GenAI client. And all we need here is we need to pass the API key, which I have it in my secrets here. Under secrets, you would find that I have this API key, which is stored. So you would need to generate that API key before, creating any GenAI client from Gemini. So let's try to import these packages, and then let's set the API key. And then the third step is we need to now generate the vector embeddings using the Gemini embedding model. And this is exactly the same example that we saw in the previous lecture, where we generated the vector embeddings using the Gemini embedding model. So here what I have is I have a list of text that I am passing inside this content, because I want to generate the vector embeddings for all this text. And for that, you need to just invoke client.models.embed content. What the embed content supports is the arguments it supports is you need to pass in the model that you want to use for generating those vector embeddings. You need to pass in the content, and you can also pass in some additional configuration. So here in this configuration, we are passing the output dimensionality, which is 768. You can pass up to 3072 dimensions, but the optimal dimensions are 768, 1536, or 3072. These are the optimal dimensions that you can use. Here for this example, I'm using here 768 as the dimension. So this is where it would invoke that embedding model and generate the vector embeddings. And here we're just iterating through those generated vector embeddings and printing it out here. So if we just try to run this steps, so this is executed now. If you see here, we now have vector embeddings which are generated for all those texts that we have in this list. So that's the first step. We are now done with generating vector embeddings using the Gemini embedding model. Now, the next step is we want to now store these vector embeddings inside Chroma DB. So for that, you will have to install the Chroma DB. So for that, you can use pip install Chroma DB. If you just click on that, it will try to install all those packages in your machine. So yeah, it's done. If you're doing it for the first time, it might take a little bit longer for you. So that's done. So now in the next step, we can store those vector embeddings inside Chroma DB. So for that, the first thing is that we'll have to create a Chroma DB client. For that, you can just say Chroma DB.client, and these are the imports. Make sure you have these imports after installing the Chroma DB package. So using this Chroma DB.client, you can get the Chroma DB client, and this is where I am setting the persist directory where I want to, have the data persisted on my machine. So this is how you create the Chroma DB client. Next step is you need to create a collection. What is a collection? Collection is just like a table in a database. So similar to how we have table in SQL database, and you also have collections in NoSQL database. Similar to that, you can create, a collection. So for that, you can use this method get or create collection. So if this collection does not exist, it will create a new one. So here I am defining a collection name codedx Chroma DB demo. This is where I want to store those vector embeddings. So this is the collection. Now, once the collection is created, before you add this onto the collection, whatever vector embeddings we generated. So if you can recall, we generated the vector embeddings inside this result variable. So if you see here, we have all those vector embeddings inside result. So here, all we are doing is that we are extracting those embeddings and storing it in this embeddings array. So that's how we can extract those embeddings, and we have inside the documents we are assigning all those text. Is this text defined? Text is where we have defined all the list of text. So what we are doing here is, along with the vector embeddings for each text, we are also storing the actual text. So you have your documents, and then you also have the embeddings for those documents, and then we are also assigning some IDs for those records inside this collection. So if you just run this now, yeah, so you can see that embeddings are stored successfully. So we are now done with storing embeddings in Chroma DB. So now is the interesting part. How do we now query these vector embeddings inside the Chroma DB? So here I have a query. This is a query. So what I would do here is that you can use now for querying, you can use client.models embed. So this is the, the important step here. This is something we covered in our vector database pipeline as well, that before you query anything, you will have to generate the query embedding. So you will have to generate the query embedding using the same model and dimension. If you don't use the same model, for example, for all our initial text for storing those vectors, we use the Gemini embedding 001. Now you cannot use any other embedding model. It has to be the same embedding model, and also it has to be the same dimension. If you just use some other dimension here in your query embedding, it would not work, because the query embedding and the embeddings which are stored inside the vector database has to match. So that is why this step is so important. So how we generate the query embedding is, again, we use the same client. Now this is the client from the GenAI, Google GenAI, and using that client .models.embed content, where you need to pass in the model name, you need to pass in the content. Here the content is your query, and you can also pass in the configuration. The default dimension is 3072. So make sure you always define this dimension. So once you have that, you would get the query embedding, and then that query embedding can be now used for querying your Chroma DB collection. So this is your Chroma DB collection, where you can say collection.query, and you need to pass in the query embedding. And here we are basically expecting how many results, what would be the number of results that it should return from this collection based on the query. So if we now try to run this, here my query is programming. So if I just try to run this, you would see something very interesting. We are getting these two text as the output. How do I write a Python function, and how can I create a class in Java? These are the texts that we initially stored inside the vector database. So if you see now, out of this text, when you search programming, these are the two texts that matches that. Now, what is interesting here is that in these two texts, you don't have programming anywhere. That keyword is not present inside these two texts, but still it is able to match those texts which relate to programming. And that's the power of semantic search. This is something you cannot achieve using the normal keyword-based search, because if you perform a keyword-based search with programming, you would not get this to text. Now let's take another example. Let's say I search in here, let's say electronics. Now if you just search electronics here, so this is what we get. Apple released a new iPhone. Which smartphone has the best camera? Now this two text relates to electronics, and that's the power of semantic search. So that is why vector databases are so powerful. This is what powers your recommendation system. That is why all the popular, e-commerce websites that you have out there, they nowadays use vector databases and vector search for performing semantic search and recommendation engine. Also, hope this video was interesting. Thanks for watching and see you in the next one.